Good morning, everybody. Good morning from Denver because it is 8:33 here now. Good late morning in New York and good evening in India. And I'm so glad all of you have joined. And we are looking forward to this webinar. Just like we are looking forward to our conference in Pune, and all of you should make an effort to come to Pune on 22nd, 23rd. On website, we have a call for papers. All the information about December conference is there in SIA. And I think many of you already know that SIA has been in existence since 1988, established in New York area, and several distinguished people have been on SIA board as well as presidents. Dr. Ravi Kulkarni was a president before me. Dr. Vinod was a president before him. So we have been tugging along as a pandemic brought a lot of misery for us. The only bright point in the misery was that we started this webinar series for every month. That gave us an opportunity to invite some very renowned people from all over the world speak to all the interested listeners here. And that has been going on very well. We have continuously done at least 45, 50 webinars so far now. So about 4 years so we have been doing this. So continuing with that tradition, I'm very happy Dr. Ramanujam from Bangalore has decided to accept our invitation as well as do the presentation. Let me introduce Ramanujam, some important, or at least the executive committee members, as you already have met. Ravi, Amitabh Datta is our treasurer. He is the treasurer. Rohit Parikh, you already know. Ishwar, I think Ishwar is there. Is Ishwar here? Ishwar, let me look at the list. Yeah, Vinod just joined. So Dr. Vinod is here. Dr. Ishwar Fadia, who was the dean in New Jersey area. Now he's retired. And so all these people are here, very anxiously waiting to hear you. So I won't take too much of my time. Thank you again for joining this webinar. Let me pass it on to Dr. Rohit Parikh to introduce the speaker, and then we will get going. You will speak for about 45, 50 minutes, and then we'll have about 10, 15 minutes questions and answers after that. Thank you very much again.
And well, I was thinking that the introduction should really come more properly from Indumati. She's his wife and she works on neutrinos.
Okay, well, Dr. Indumati, would you be...
No, I was just joking. Don't interrupt.
Oh, I was just joking. I'm sorry.
I was just joking. Right? No, I met Ramanujam in 1985. That's a long time ago. That's like 40 years ago, right? And we submitted a paper to the Logic of Programs Conference, which took place at Brooklyn College and CUNY Graduate Center. And then something interesting happened that he decided to stay on and study in New York City. But his application for a student visa was put on hold. And so he did not have to go out because the application was still under review. But at the same time, he couldn't officially be a student because the visa has also not been approved. So he took courses at the Graduate Center and getting of course, all A's in all of them. And then eventually, just about the time when he was set to go back to India, his visa was approved. So that's the immigration service. And Paul Krasuski is here, and he also played a role in it because since Ramanujam had no means of support, Paul Krasuski put him up for free in his apartment in New York City. And they've been friends since then. Krasuski has gone to India many times, and Ramanujam has come and said, now, Ramanujam and I worked together largely on the logic of knowledge, about what knowledge means. And I'm sure that Ravi Kulkarni, who for some reason goes under the name of Ami Deshpande, is interested in that because there is because there's a lot of work in Indian philosophy on epistemology, right? And that work needs to be brought into modern times. Okay, so Ramanujam is also very keenly interested in education. This is separate from his research, and I think he's going to talk about his work in education. My hope was that he was talking about research, but I can see that education is more important than research. So here goes, Ram, please.
Thank you, Dr. Parikh.
So thanks very much for the introduction and for the invitation. Thanks for the invitation. There's a caveat that this is not an analytical talk, it's an experiential account. Yet I hope there will be something of interest to academics. And so please ask questions anytime. And also here is my Gmail, which is easy to remember for anybody who wants to continue the conversation later on. So can you hear me? It's okay? And the audio is okay?
Yes.
Yeah.
Okay.
Perfect.
Okay. So this is basically a personal account of, like I said in the abstract, I've been involved in education in different ways. And so this is an account of my experiences generally in education. So Rohit mentioned that I was in CUNY in 85, and then I came back to India and I joined the Institute of Mathematical Sciences. And soon after, I started doing some work in adult education. And this is from those days. Okay, so I was talking to Velam, vegetable seller, urging her to join an adult education class. She had dropped out of school many, many years before, and I was giving my usual pitch that she should join the adult education classes, learn. She was interested, but she hesitated when she learned that she would need to spend 1 hour every day in the evening for 3 months. Well, actually, it's longer. It takes at least 6 months, but yeah. And then there are 3 books. She said, 3 books, for an adult learner to come, non-literate person, 3 books. Yeah, that, no, I don't have the time, etc., etc. So then she asked me something. So she asked, after completing the 3 books, will I be able to earn 10 rupees more every day? Okay. Now, this is a reasonable question, isn't it? That, I mean, somebody who works all day carrying vegetables on her head and on a basket and on bags on her shoulders, itinerant vegetable seller walking around all day selling vegetables. These are the people that you see in India even today, right? And this used to be much more common in those days. And so if I'm investing that kind of time, can you give me a guarantee that, I can earn 10 rupees more every day? Now, I had this PhD. I had come from Tata Institute of Fundamental Research. I had been to CUNY. I was, did all this, and I was in this. And I was at the Institute of Mathematical Sciences. This is like a slap in the face. How do I answer her? There's no guarantee. How do I say there is no guarantee? Right? So I don't know what you would say when faced with such a situation. I mean, it requires an honest answer. So what does one say? Now, I don't know what, I have asked this question many times in many groups, and many people try to say, no, we can't really say yes, education is more. You can say all sorts of things, but the thing is that do we give her the right to ask this question? Right? And my way at that time was that you have to say yes. It's kind of a moral responsibility and make it happen somehow. And that's an interesting story in itself. And actually, she started coming to classes. And so first thing we needed to do was throw away the books that we had, the literacy primers for adult education, because the way those books looked at mathematics was like, there are 8 birds on a tree and 4 fly away, and how many are left? Now, that's an insult to her intelligence. I mean, she's selling vegetables. I mean, what she needed was lessons in optimization, right? What she needed was lessons in expectation, in probability. But those are not what adult education classes teach you. So how do you look at what she does and what you can do to enhance her earning capacity, as it were, right? That's the sort of thing that business schools teach, right? But that's what she needs. Well, that's an interesting story. If somebody is interested, I'll go into that. But here, it's only to say that when you look at education from below, this is the point I want to make about looking at it from above and from below. That's the words that I used in the title. Things look different, right? And your needs, your aspirations, these are the things that you come to education with. Ironically, she never asked that question in relation to her daughter, who was going to school at that time and was in class 7. She did not ask, my child is going to school. Will she be able to earn 10 rupees more every day than me? She has took it for granted that education gives you that, right?
Yes, good
So
point. Yeah.
nobody is giving the child a guarantee either. There is right to education, there is compulsory education, but nobody says you come to school for 10 years, we guarantee you this earning capacity. So what is going on? So your expectations of education are very different. This is the point I want to make. And as I said, I can go more into these details of. I just want to quote a few episodes and raise certain questions. The point is not to emphasize the economic aims of mathematics education. Now, India is moving towards universalizing access to school education, but what kind of mathematics and science is being taught? What is our real vision of mathematics education for all? This is something that education for all is a slogan that you hear everywhere. But what is really our vision? How do we assure quality in mathematics teaching at all levels, even for the adult education class, as it were, for any levels? Now, large-scale systemic assessments offer a fairly bleak picture. Now, question is, what steps need to be taken by whom? And on the other hand, India is rich in diversity of resources. There is a deep cultural and historical tradition. There is tremendous respect for mathematics in society. I think probably more in Asia than I see in, let's say America, right? So 1,000 initiatives were interested individuals, groups, many positive and constructive efforts, but that do not seem to scale up for the kind of scale that India needs. Voluntary groups acting out of enthusiasm and concern, corporatizing in some cases, whatever. So there is different communities. Here is another episode, again, adult education class, early 90s. Now, learners would often come very late, and the reason would be water lorry arrived. I mean, this is something that you need to know. Urban slums in India where water supply was not piped. And so drinking water, this water lorry would come. The water that they could get from the pumps that were there were not safe to drink. Okay, so this is the situation that would be used for other things, but not for it. So someone observed that the metro water lorry was coming on no fixed days of the week. So why is it that class, it had come on Sunday 2 weeks earlier, on Saturday the previous week, and so on? So why is it that every time people say water lorry? So that seems the people coming late seems to happen on Mondays, on Wednesdays, whatever. No, the water supply was every third day those days. And at least this metro water lorry was coming every third day. Now I asked the class to argue this. Now, as long as water supply was regular, lorries must come on all 3 days of the week eventually, all days of the week eventually, right? If it comes on Monday, then maybe it comes on Thursday, but then it would next come on Sunday, then it would come on Wednesday, then Saturday, and so on. Eventually, over a period of time, it's coming on, if your class is happening on all days, people are going to be late on Mondays or sometimes on Tuesdays, sometimes on Wednesdays, sometimes whatever. So we had a nice discussion, and the class was indeed convinced of this. Now, what I'm pointing out is a certain kind of mathematical reasoning and argumentation that is happening in that class. And this is not formulas. This is not about formula. This is not about arithmetic. This is actually some fairly detailed mathematical reasoning and argumentation that is happening in class. Let me shift to something else. 1994 Joy of Learning Festival in New Delhi. Okay, so this is sort of thing that we used to do a lot of those days, adult education, but also working with children. But with children, it is a matter of turning these things into games. So here is a game where n children are seated in a circle. A book is passed around. Each child is passing it to her neighbor. So let's say K is 3, N is 20, starts out with 1, passes it to 4, passes it to 7, and so on. And then you ask, has everyone got the book? No. For some values of N and K, everyone gets the book eventually, and for some values, only a fraction get it. I hope you can see the connection between the water lorry and this game. And it's basically the same thing that you're talking about. Now, after several trials, the children get a characterization. Again, it is the process of discovery that is here that is important, the argument and the reasoning. Here, of course, you see 20 children. For some values of K, everyone gets. For some values, everyone doesn't get. So they start analyzing. You throw away one child and say 19, and now everybody gets every time. So what is going on here? And, eventually people get it. The children get it. And they draw many beautiful pictures because you can, draw a clock with 20 numbers, and what you pass, you can draw as figures. You get many, many closed curves. Now, this game can lead to an interesting exercise on finite groups at an undergraduate class. And I have actually done such exercises as well. So what I'm pointing out is that the unity of mathematics, when seen from all directions in every classroom, with whether you call this game a classroom or not, right? These are contexts, right? In every context, there is something that you can do, and then the kind of mathematics that you are doing is something that is closer to the context. It is closer to the people whom you are talking about, and so this, I think, is one of the very important things that I want to say about the view from below. Now, let me shift gears and talk about something slightly different. Many of these things that I've been talking about as part of a voluntary group called Tamil Nadu Science Forum. I mentioned it among my affiliations right in the beginning. And it organizes interactions for scientists with children. And this was in a village near Arupukote. And I'm the scientist, right? I mean, I go interact with children. Yeah. So, and I go there in the evening, and typically we would go in the evening, go around, and then have a telescope, a 6-inch telescope would do. You can do a sky show at night, and that was the thing. So, and when you go, children take you around. In this case, my 12-year-old guidance chief, a girl called Kuruamma, and she takes me all around. She has plenty to say about the trees, the plants, the medicinal herbs. I mean, she can point to some plant and say, this is very good for stomach aches and so on. Now, birds, insects. And every time I keep saying, I don't know these things. I'm a good town guy. I mean, what do I know about trees and plants and names of all these things? But I'm the scientist, right? And she can't believe that I don't know all these things, right? She knows about, I deliberately put this, brown sugar doesn't mean what people think it is. What it is, typically what you produce in the country. It is unrefined sugar. She knows properties of molasses. She knows how to do these things. She can identify constellations in the night sky. There are many words in Tamil for these things, and she knows them. Next morning I leave. I say, Kuroma, you'll make a great scientist someday. And all the children laugh. Kuroma says, sir, I never get more than 30 marks in science, right? So, will Kuroma become a scientist? That is the question. Again, I raise this question in many, many forums, maybe at the Indian Institute of Science, at the University of Hyderabad, many, many places I raise, and people say, yeah, will she make a scientist? She knows many things, but the probability is that she will not. And somehow we accept that that is a fact of life, right? So what is going on with our view towards education? Here's another scene. Here is another village, interaction with children. And typically adults do this all the time. When you meet children, you ask, what do you want to become when you grow up, right? And when, anyway, at that time, I don't know how children think now. You go to villages and ask, very rarely do you come across a child who would say, I want to become a scientist. Okay, here was one boy, Manigandan. He says he wants to become a scientist when he grows up. And I, ask, what do you want to do as a scientist? And he says, I want to design an idli machine, right? And yeah, so, okay. After probing, it turns out that his mother is like one of those that you would find in Tamil Nadu. If you go to rural areas, you get off at the bus stand, you will find a woman, many women selling idlis from a basket, and she's one of them. And a single parent raising 3 children. And so here is a child who's helping her at home every day. And he says he wants to design an idli machine. It's a very natural thing for a child to think in such a context. What are the chances that, let's say, you wave a magic wand, right? He makes it. He makes it through our entrance exams. He makes it to the Indian Institute of Technology. What are the chances that he can design an idli machine or will do such a thing even after all this? Now, how is it then the education with all its structure cannot address something that is very natural for a child? Now, there is a huge gap between the perceived goals of science and mathematics education and what actually takes place in the classroom. And here, a classroom is many, many contexts for me. It's not only, what happens inside the four walls of teaching. How does the prevalent curriculum and pedagogy generate manpower for economic growth in an S&T-based society? These are from policy documents. This is typically what you hear from education policy. How does it create the scientific temper in children? This is what it's supposed to do. Does Kuroma have any hope of joining the experts, middle order workers, and scientifically literate citizens that the education policy calls necessary? Or can she expect to understand the processes of science and mathematics, internalize them? Right? This is again what education policy wants you children to do. Now, there are various systemic issues here. Her identity as a rural Dalit girl, child of agricultural laborers. She's a first generation learner. There are no books, no gadgets at home. Her school has no real library or laboratory. I mean, you have a shelf of books from which, which is kept locked up, a shelf of things that are used for showing experiments. That's about all that, which is usually kept locked up, opened up, and for demonstrations and put back. The idioms of modern science learning are alien to Kurvamu. There are no planetaria, there is no science city, no internet in many of these. So, okay, this is changing, but very broadly, this is the case. The state supplied textbook is her sole link to formal science. Experiments are best seen from a distance once in a few weeks and at worst non-existent. It is not that she performs experiments and learns from them. What Kurvama knows is not acknowledged as knowledge in school. Her extensive familiarity with the world around her, her hands-on experiences with all processes around her, her ability to make things grow, to shape things and connect to nature, are largely considered irrelevant. In school, she learns that whatever science might be, it's not something she's at home with. School typically teaches her to see technology as given, not constructed, right? So we cannot be romantic about Kuruma's traditional knowledge either. She needs modern science, the secrets that books hold. She needs to travel beyond experiential learning. She needs even more the language of science that insists on quantification, on evidence. When she cannot speak this language, entry into the world of science is denied her. As in other forms, language is a powerful means of social exclusion, perpetuating inequity. The languages of science and mathematics, I want to say a little bit about it, because this is something that when you go into the classroom, this becomes a very important thing. Mathematics insists on a stylized mode of communication. The ability to speak this language is essential for developing mathematical thinking. Science proceeds by classification, quantification, estimation, approximation, simplification, again developing a language of its own. Note that we are not referring to disciplinary vocabulary here. This is not about learning in the mother tongue versus English. It's the word narkaram in Tamil is as alien to Kuruma as quadrilateral. No mother speaks the tongue, right? And so it's learning a different kind of language, and that is really the problem in the classroom that she has access to. So, in fact, I would say for a teacher, the most difficult part of mathematical talk, if you want talk in the class, is really listening. Here is something from a math exploration that I was doing in a Chennai corporation school. Jayashree is here, I see. She was the one who started this exercise. So, how many right angles can a polygon have? You just ask this question and, students come up with all kinds of answers. And here is Mani, one boy who says, turn 4 times, you're back where you started. In between, you can go out and come back any number of times if you are allowed that. Now, he said this in Tamil, and I've tried to roughly translate what he said. Now, what is he saying, right? If you're talking about 4 right angle turns, right, you are back where you started. That's what he says. But then he's also saying, what is this business about? If you allow me to go out and come back, I can do it any number of times, right? He's actually making a complex assertion about convex and concave polygons and traversals. But as a teacher, am I likely to listen to him? This is the point, right? If you're talking about convex polygons, right? Well, if you're, you have 4 right angles, you're going to get back to where you started. But if you allow concave polygons, okay, he's trying to tell you that it can have any number of zigzags, right? And so his understanding of a polygon is through traversals, right? Now, I need to know my geometry very well before I can make sense of what this child is thinking. But this is talk. This is mathematical talk, right? Mani is talking mathematically, right? He's thinking mathematically and he's talking mathematically. But how am I as a teacher likely to listen to any of this at all? In this case, it is the tyranny of textbook language and classroom discourse that needs to be questioned, right? Because it doesn't allow for such a talk at all. Okay, so when you allow children to talk, then funny things happen. Okay, so here I was talking to some children, the math club. The way it started was we were talking about projects, and then the children said, look, science projects we can do. How can you do projects in mathematics? Mathematics, you can't do projects, right? So I tried to convince them that math projects could be fun and gave examples from everyday life. And here I was trying to say math is everywhere, kind of things that you tell children. And this is how you put your foot in your mouth. Naveen, boy, comes to me and says, I like mathematics very much, and I would like to do a math project. I was very happy. Okay, here's a boy who likes it immediately. Then he says, I also like spiders very much. And can you tell me a project that I can do with mathematics and spiders? This is how children think, right? Now, as I said, I had put my foot in my mouth. What do I do now, right? I say math in everyday life, and the child comes back and says, I like spiders. So now give me a project, right? So I just said something that came to my head. You can think of spider's web as a series of sequence of concentric polygons. attached by rays, and there's a bug in some place and a spider is in some place and it walks on the web. So you can do something like this. And then I left. It was a math club. And then later, this was in the context of an exhibition, and this child had done all sorts of things. I mean, I met him after a month or so. So he studied this as a sequence of concentric hexagons with radial lines connecting the vertices. He came up with formulas for perimeter, and I put in quotes because how do you even define perimeter? This is all he knew. He knew perimeter and area of geometric figures. He came up with formulas. That's what you're supposed to do, doing mathematics, right? He came up with a procedure for the shortest route by which the spider at one point could get to a trapped insect at another point. Only a child can worry about how fast a spider can catch a bug in a web, right? Note that he had no idea about Cartesian coordinate systems. So he needed a whole language to talk about it. And he came up with all sorts of stuff that didn't make any sense without your knowing that that's what he's saying, right? I recognized that he was looking for the shortest path in this. He didn't know graphs, he didn't know coordinate systems, but he could explain what he meant because that was his passion. He filled up notebooks and figures showing what happens because how do you see as a child, how do you see spiders' webs? You see it in corners of buildings, right? But then, you pull one corner of the web and then, it looks distorted, right? He had pictures to draw. And he was frustrated that he couldn't find formulas for the areas of these shapes. This is a very creative frustration. He was a little mathematician. In fact, I invited him to the Institute of Mathematical Sciences and got him to give a talk with, my colleagues all listened to. Now, my point is that mathematization involves a range of processes. There is abstraction and representation, use of patterns, use of heuristics, estimation and approximation, making connections, formal communication. All these are what doing mathematics is all about. But then if we want such things to happen in the classroom, we need to shift focus from content to process. Someday I hope, you ask, what are you teaching? Right? And the teacher says, not I'm teaching algebra today or geometry today, but I'm doing visualization, right? Or something like that. How do we give primacy to process? Now, if you actually look at the process of doing mathematics, it's not merely learning content. It means selecting between representations, devising new representations, looking for invariances, observing extreme cases and typical ones to come up with conjectures, looking actively for counterexamples. Now, this is a secret that nobody tells you until you get to PhD. It's only in graduate school that you learn that what mathematics is about is actually looking for counterexamples, looking actively. This is Rohit for me. Anything I say, he's always looking for a counterexample, right? But that's how you do research, right? That's what is the exciting part of mathematics. It's not about learning somebody's proofs. Proofs come much later, right? And another thing is that it's only in mathematics that n equal to 3 is okay, n equal to 4 is looking difficult. And then you say, let's just try for all n. And you get a much better insight, right? Generalizing problems to make them easier to address. This is unique to mathematics. Building on answers to generate new questions for exploration. And so on. These are mostly missing in our classrooms. When I say classrooms here, I would say, from primary to graduate school, right? Or, undergraduate or master's classes. It doesn't matter, right? None of these processes can take place in classrooms where children are silent. We need to hear arguments originating from children's minds based on their concerns stated in their language. And language, again and again, to me, is a very fundamental issue. I would say that it's the spoken language that's most important. On the other hand, what dominates a classroom is the language of the textbook. The tyranny of the textbook permits neither the teacher nor the students to approach the matter as something to be explored. It's something given, and you learn it as given, memorize, digest, reproduce. It's not something that you explore. Well, a culture of silence is death for an active learning classroom, right? Now, here, Now we talk about the policy talks about the scientific temper. Now, if you children do not talk, children are silent, what scientific temper can develop? What critical thinking can develop? Here is a more recent one. So during the pandemic, Tamil Nadu government was distributing something called Kabasura Kudineer. It's a herbal thing. And now this has been very good for treating jaundice, turns out. And many people believe that this was or maybe I'm mixing up, it was some other herb that was good for jaundice. And Kabasar Kudineer, it's a drink made from these herbs, which is generally good for respiratory illnesses traditionally. And they actually distributed to COVID positive patients in 2020. 2021, when we had Delta and all of us were down with COVID in our family, we all got sachets of this Kabasara Kudineer, and I drank it too. Okay. Now, I was doing an online webinar, like Professor Kulkarni was just pointing out that one thing that pandemic started for us was all these webinars. So I was doing it for some webinar in a city college, and I was having discussions, and I asked, is Kabasara Kudineer a cure for COVID-19? Remember, this is sometime maybe in August 2020, around that time, I think. No vaccines were there was no, so vaccines were still being researched on. Nobody had a cure for COVID-19. And so I asked this question, and we did a Zoom poll, right? I mean, in Zoom, it's easy to set up polls, and yes and no. And interestingly, it was deliberately done that only the answers suggested were yes and no third option provided. And students had a yes and no. And then I asked questions about why do you say yes or why do you say no? And they were all quite vehement as to why it is yes or no. And typically the yes was, traditional medicines are good, etc., etc. Or no, that's all nonsense, right? The discussion was largely on an emotional play. Whatever happened to evidence-based reasoning? Nobody was talking about where is the evidence for believing in this to say yes or to say no. People should have said, you can't answer this question without evidence, right? Give me data. Now, if we do not, that's what I mean by a culture of silence, right? There is no demand for this thing. Then what is science education doing out there, right? And here, what is historical? Now, this was a proposition offered to an undergraduate mathematics class. Now, I've done similar things with school teachers, with school students, high school, undergraduate classes, teachers in universities. Experience is not very different. Okay, here you say one proposition. In India, we had some calculus 2000 years before Newton. In India, we had some calculus 200 years before Newton. We never heard of any calculus in India until the Europeans came here. So you have these options A, B, C, and ask, take a vote. What do you think? And many, many, many groups in India, the opinion is almost always divided between the first and the third. There are people who say, yeah, everything was known, and how do you come up with these numbers, 2000 years? Among those groups, many people can't even say which year was Newton's Principia. 2000 years before, what was happening? Nothing is known, right? But there is a belief that we had calculus 2000 years before. Or, it's all nonsense. Calculus is all the Europeans. That's all some. Now, most people hadn't heard of the Kerala School of Mathematics or Madhava and work of that kind or infinite series. But my point is that there is no historical consciousness, right? You are not approaching any of these things based on evidence, data, understanding of the historical roots of concepts. You're only looking at it as a matter of pride or no, right? So the one thing that I see, entirely missing in these discussions is critical thinking. So what is the point of mathematics and science classrooms that do not develop critical thinking? Now, for our Kuruvamma and Manikandan, if they are to join what the policy statements tell you, the S&T manpower, how is this education providing any of that? Now, like I mentioned, the abstract, I've also been through all these things, been part of many committees. Okay, so let me just mention a few just to set the context. I was part of the 1996 Tamil Nadu State Committee on Reducing Burden in School Education. That has an interesting background. In 1993, R.K. Narayan spoke as a Rajya Sabha member, spoke in Parliament on how it was very painful to see children carrying huge loads of books. And he said, their backs are almost bent over with the weight of the books that they carry every day. But are they getting any wisdom at all from all this education? Right? So, and then Yashpal Committee was set up by the government, and duly Tamil Nadu also set up this thing. Unfortunately, what we in the committee spoke on the burden of incomprehension in the classroom wasn't listened to very much. But Tamil Nadu actually introduced many, many reforms, and actually what of kind of textbooks and the kind of things that were being done in school. But I was in the 2002 State Planning Commission, the Subcommittee on Education, again looking at various policy implications, giving whatever recommendations. I was part of the 2005, the National Committee, the Yashpal Committee on National Curriculum Framework. I chaired the National Focus Group on Teaching of Mathematics. And this was all experiences where you could see, you are grappling with very similar questions, but you are looking at it from above. You are looking at policy prescriptions. You are looking at curricular framework. You are spelling out what curriculum should be. Some of the things that I quoted about processes from content to process is all from that exercise. Then I was part of the 2017 Tamil Nadu Curriculum Framework Committee. I was more recently part of the State Education Policy Committee. One thing I can say in all these is that the Velama who sells vegetables, or Kuruama, with her knowledge of nature, sitting in the science classroom, or Manigandan, who's wanting to make an idli machine, are largely invisible. And that is the nature of things, because this is a huge populations. You have a global view, but the global view from high above doesn't permit the problem with the classroom, the talk in the classroom, the kind of thinking that happens in the classroom, the kind of sharing that or doesn't happen in the classroom. Now, here is one child. So this is now we are talking about many policy people love to talk about the use of education technology, the use of AI today, and how this is going to revolutionize education. We talk about all these things. I don't really understand. The children's own view of the future is also very interesting. So I was giving a math club talk in a school, and one girl, Vani, came looking very worried. We were talking in that discussion, we were talking about the 21st century, the future. We're talking about solar energy, a lot of very interesting things, actually. And then she comes and she says, look, I find mathematics very interesting, but it's very difficult. And I'm sorry, we had talked about things like climate change, climate models, how mathematics is revealing the world to us. Then she asked me an interesting question. Will they teach root 2 plus root 3 even 50 years from now? Okay, so look at where this child is coming from. Because root 2 times root 3 is easy for her. Root 2 plus root 3, how do you even envisage such a thing, right? And how do I construct such a thing? What is this about? And if I'm struggling with it, and I can in fact think about, Sulava Sutras, we know, in the Vedic period, people knew about square root of 2. Not very difficult to think of them knowing square root of 3 either. Like Babylonians had some idea of square root of 2 and square root of 3, right? I can show you things from Babylonian tablets that tell you that these people were actually thinking about such things. Now, I don't know whether Babylonian children or children sitting in patshalas and learning Sulava Sutras were concerned about what square root of 2 plus square root of 3 means, right? And this child is worried about whether even 50 years from now, whether math classrooms will be teaching this. And what she means is that, will it be as alienating and incomprehensible 50 years from now? Well, it always was, and it always will be. Because the way mathematics she's engaging with is something that has been there for a very long time. Here is another child that I want to mention. So this is this is a very interesting experiment that is being done in a slum, a large slum in Mumbai called Dharavi, where they were actually, putting computer centers and getting children to learn to use computers. So I was invited to one, and I was there for talking. And then one girl called Mehrun wearing a hijab, she comes to me, and then she says, "मुझे rocket में जाना है." Okay, so I want to go on a rocket. Now, I thought here is in a computer center. She wants to learn about space, about this thing. So I started showing her various things to do with space science, about rockets and all. Then she told me, "Look, uncle, you show me all that fine, but I want to go on a rocket." Right? मुझे rocket में जाना है. Don't give me don't show me all this about space science and about rockets and so on. I want to go on a rocket. What should I study? What degree should I get? Right? Tell me what work I should do so that I'll go on a rocket. These are children's dreams, right? So she thinks that there is a particular study that she can go to and she can work hard, get a degree, which will get her to go on a rocket, right? Now, there is a big issue here. The big issue is, now it's acknowledged the world over that poor performance in mathematics leads to poor self-image and self-esteem issues among a large number of teenagers. According to the UN, the population of adolescents in the world is around 1.3 billion. I'm sorry, I should say WHO. This is a WHO figure. UNESCO also quotes similar numbers. Now, I would estimate that the self-esteem issues referred above apply to at least 250 million adolescents at any point of time on the globe. Right? At any point of time on the globe, there are about 250 million adolescents going around with self-image issues related to mathematics, right? Saying, I can't do math, right? And and whatever self-image issues come out of that. Major proportion of them are in Asia and Africa. In India, I would put it at somewhere around 50 million, and principally from the socially and economically disadvantaged sections of society. Not necessarily, I mean, it's all across, but especially so. Perhaps the best answers come from public engagement in education, and that's what I've been talking about. Much of my learning comes from the activities of Tamil Nadu Science Forum that I keep mentioning. School teachers who have learned from Tamil Nadu Science Forum have provided many resources now for the state education system. Education requires conversations across many compartments: scientists, communicators, science communicators, university teachers, school teachers, education researchers, administrators. This is not easy, as the school is at the bottom of the education pyramid. Now, this thing that I've been talking about, I just mentioned at least in one slide what sort of things that happen there. It is set up as a group for science communication, science popularization, and science education. So I've mentioned the Joy of Learning Festival, science festivals to promote love of experimentation, science projects of varying duration. I referred to math projects. I mean, when I say science, and I'm including science and mathematics. Typically, that's how this is done. And the technology sessions, integrated modules, like I said, science in the kitchen, light, waves, science and sport, many things. Range of exploratory projects inside and outside classrooms. Just few examples and then I'll stop. Here is something that, that you see in Tamil Nadu all the time. These are called columns, and these are, drawn on the ground, on the street. You will find fairly complicated drawings. I mean, these, particularly when you see D, E, and F, the ones below, these are called pulley columns. These are curves that twist all around, closed curves that twist around a dot pattern. It's a dot grid around which, you have closed curves. These are drawn, and it's, there is a gender dimension also, but you can do, wonderful explorations with columns. You can classify columns based on number of closed curves in them. You can look at symmetries and transformations. You can look at curvature. It depends on where you want to go, right? I've done this in adult education classes, school classrooms, in workshops with school teachers, formally communicating columns. This is not at all an easy exercise. And Professor Rani Suramani and her group did a lot of work in Madras Christian College on formal languages for describing columns. Right? Now, there's a lot of mathematics you can do. I want to mention one particular project that I was doing with class 11 children. There is a big flood in Chennai in December 2015. So now the schools were actually collecting material and, making tents for emergency shelter for use by a family. Now, if you're designing a tent, how much height is needed for sleeping or on your side? Can you make use of the whole floor space? What's a reasonable height at the center? What should be the angle of the walls to achieve the height needed over much of the tent? Do you want a tent to fit the average person? Who's an average person? What are the dimensions? What scale will you use for diagrams and plans? Now, these are all, for children, none of this is easy, and you're actually designing something, right? Now, if you actually look at curricular areas, many intersect during the discussion. They have to handle data, they have to do work with geometry, measures, 3D shapes, 2D representations, nets and construction, whole lot of stuff. Trigonometry, dynamic geometry software, you could use a lot. Economic, how much material you need, how much it costs, you want to buy the cheapest thing, and internet is extensively used. So these projects, when I'm talking about explorations and projects arising from contexts, right, that you can do, they bring in many processes that I was talking about. Here is an exhibition that we were part of. Down below, there is the logo of the Institute of Mathematical Sciences with the Mathematicum in Germany and the Goethe Institute, where we actually set up an exhibition which ran in different places. And it's really mathematics you can touch. You can see the soap bubble there. That's an example, but there's a lot you can actually do. Okay, so let me get back to the beginning. Does any of this better Kuruma's prospect of becoming a scientist? Well, changing our classrooms to exploratory centers offers far more space for Kuruma and Manikanda. Much of math education today has little organic connection with nature, science, and technology. Well, let me skip this. Biggest systemic difficulty in all this is teachers' understanding of process and mathematics education and lack of systemic means to promote it. In Felix Klein's words, mathematics teachers suffer due to a double discontinuity. What does it mean? Well, many teachers themselves not negotiated these transitions successfully and lack introspection on these difficulties. As when they were learning in school, they had all kinds of difficulties. They go to the university, it's a different kind of mathematics, they learn that. So they forget school mathematics, they return to school, that is the second discontinuity. You've forgotten how you learned all this, so you don't understand the learning difficulties that children have. So the shift from content to process requires knowledgeable teachers, but most teachers do not have personal experience what it means to do mathematics of the kind that I said over time, exploring questions which have intellectual purpose, not pedagogic purpose. So clearly there is much work to be done, but by whom and how? Well, let me again skip these things. Point is that it's not just psychologists, educational technicians, specialists, new age prophets, recommending AI tools, socio-cultural factors. It's all interesting, but in the end, inadequate. Let me end with a quote from William Thurston, because I said it's really collegiate efforts where I think the answer lies, not from policy committees, not from classrooms, but so William Thurston, writing in 90, way back, says, I'm optimistic that our nation, he's talking about America and problems of American education, but this holds for everyone, I think. He says, I'm optimistic that our nation will find solutions to these problems. Problems arising from failure of understanding are curable. We do not lack for dedication, resources, or intelligence. We lack direction. The needed reforms will take place not through governmental action, but through collegial cooperative efforts. good mathematical ideas spread very rapidly through informal channels in the mathematical community. As we all turn more of our attention to education, good educational ideas will also spread rapidly. And whatever I've been talking about Tamil Nadu Science Forum or work of this kind, I think it stems from the same kind of understanding that finally it is these involvement in education, engagement with education by everybody that can actually solve problems of education. We stop with this. Thank you.
Very good.
Thank you. Sorry, I took a bit longer than I intended.
Good job. Thank you very much, Dr. Ramanujam. That was wonderful. That was very educational too.
I have a question and comment.
Yes, please.
Can I go ahead? Professor Ramanujam, I know from Indian culture and how our past has been and what we have taught and what we have learned, we somehow do not like to share our knowledge. We want to keep it to ourselves or only pass it on to those whom we select after really many, many tests. Our literature, our scriptures are full of that kind of behavior. And I know, like you were talking about column or column, if I'm pronouncing correctly, it is extremely skillful thing. But what we appreciate in the West is theory. Can we convert something into theory? Because theory can be passed on to others. Whether it was Newton or it were other scientists, they turned things into theory. Falling of the apple had been going on and everybody knew and was aware. But when it was turned into force of gravitation and they calculated and all that, that is what has lacked in India. I'm not saying they should give out all their secrets and all their knowledge, but I'm just saying, as my observation, I'm really look at Seleucus when he came and he found out at an ashram, a father and son had a book that had treatment for everything, all kind of problems. And he wanted to take it by money, by force and all that. They burned it. They did not pass it on. So how do we approach that kind of philosophy? Should we change? And this is my question to you. Would you like India to change from what it did for thousands of years? Or should we just stay the way it is, only give it to those whom we find to be most deserving?
Yeah, I think, well, you've answered it yourself. I think when I say education for all, right, mathematics education for all, I really mean that. I think, when we take universalization seriously, right, that what I'm trying to say is that universalization is not simply a matter of bringing children to school, providing, this is how in policy you translate into providing schools, providing infrastructure, providing teachers, providing textbooks. But it's not only that it is about what you do in the classroom, right? And like you said, that's why I use the word mathematization, right? When you have a context, when you have something, when you see something, can you mathematize it? You're talking about theorizing. I call it mathematizing. But it is that activity. I mean, B.I. Arnold says that this idea of mathematization or, involves many transitions, right? From the physical world to the abstraction, right? And the kind of representations and abstractions that you come up with. Those are the things that you need to engage in. And it's only when you do that you can actually, see the world from the viewpoint of science or mathematics. And for that, it is the language of science and mathematics that's absolutely essential, right? It is by learning that language of quantification, right, that you actually learn to look at practice and theorize. And I think
what I read from this is, and I want clarification, that's why I want answer which is direct. So you are in favor of releasing all kind of knowledge and sharing it in the form of books or theory or without any reservation?
Very much, very much so.
All right, thank you.
Dr. Indumati has a question. Go ahead. Just unmute yourself, Indumati.
Yeah, I had one comment and one question actually. So, Jam, I am a little confused by how you ended, because you were talking on one hand about parts of these committees, and then you said it's not so much just intervening at the committee level, but you need to do something different, and that different is probably working from below rather than above. Is that how I have to understand what you say? That is, that is
from
a
below
kind
and
of
with public engagement.
yeah. And the other thing, because you talked about being part of so many committees, and now there's this new education policy, right? So this new education policy is actually very sweeping in its kind of reach. But does it actually address any of these issues that you have raised? Is my question.
Yeah, the thing is this. The policy statement is full of superlatives, and it says many, many right things. My problem is that I've been on many committees, so I know how easy it is to say many things. In fact, I mentioned that as part of the National Curriculum Framework 2005, but the vision of mathematics education that I spoke about actually was written there as well. But what comes in the way is the reality. Working with the reality, that is why I'm talking about working from above, working from below. And short answer to you is that I do not see that in the NEP 2020. But I can give more detailed answers if somebody is interested.
Yeah. Thanks.
I have included my question in the chat.
Yes. Okay. So there are a few, I think, there is a comment about your...
So like the group theory or if it can be explained, I guess it would be very hard to understand the group theory. And
so what I was talking about was you were, for instance, in this game or, with water lorry. Is that the example that you were talking about? Yeah. So see, the thing is that if you think of the lorry coming today, right, which is Sunday, right? So you think of it as 1 plus 3, 4, 4 plus 3, 7. Now that becomes 0 again, right? And then you go to 3, you go to 6, you go to 9. So you see how there is a movement here. That's what children are also doing. They are sitting in a circle, 1 to 20, 21 is again 1, right? So you keep passing. Now, when n and k are relatively prime, right, then you will actually get all of them. And if they have common factors greater than 1, then non-trivial factors, then you cannot. Now, this is something that you can actually talk about a group action, you can talk about orbits, and you can talk about the order of the group and so on. So I'm saying these are explorations that you can take at whatever level that you wish, right? So, and this is typical of mathematics. You can engage with things at their own level. As long as you're willing to think mathematically and talk mathematically, the language provides, certain ways of thinking and doing. That's what I wanted to illustrate in this.
But now let's take the example of square root of 2 and square root of 3.
Yes.
So a student will say, what use is this? Why should I know?
Okay. So this again, it depends on where the question comes from. It depends on what you have done in class until then, right? So for instance, if you have students constructing square root of 3, right? Square root of 2. Square root of 2 is easy to construct, right? You take a right angle triangle with 1 and 1 unit, the diagonal will give you root 2. Now you take that as the base and have another perpendicular of unit length. The diagonal of that right angle triangle will give you root 3. You can keep constructing these things. So they get a feel for all this. You can construct square root of 53, right? Because you can take something of length 7, length 2, and then 49 plus 4 will give you 53, and you can construct So you can go on like this. You can do a lot, actually. Now, my point is that even all that will not give you, it'll give you a feel for what you're saying. So you don't have to talk about the use in some sense. Children don't necessarily need use. They need context. They need constructions. They need a feel, right? And
they still also need the language.
Yeah.
They still need the
They need
terminology
the
of
language. They need the language. They need to talk. They need to think. They need to describe. They need to construct. They need to, do many things. So you can do a lot. But root 2 plus root 3 is hard. It's not easy. So, that's more technical discussion required there. But to point out that she had grasped the essence of the problem there. The school has a section called, surge and radicals, right? Now, that's really bizarre because what you do with them is not easy at all. And she was right to express a concern, right? That 50 years from now, will children be doing this? But by the way, Muthukumari is here. She's one of our teachers of Tamil Nadu Science Forum, and she has put up some very interesting things on the chat as well, right? Kuruma never had a chance to enter into the science world even today, right? And like she says that, textbooks don't really have access to children's experience because they do not understand student psychology, right? That it's not just that, and she talks about teachers not having any say in or influencing textbooks. Now, yeah, when will textbooks be student friendly, right? So I think textbooks, I mean, Muthukumari's comment is very important because textbooks matter a lot. But it's not only textbooks. I'm saying, teachers need to be empowered. Teachers need to be able to engage in these processes. We need to change, that culture of silence in the classroom. That's what I would say. I think Amar wanted to say something.
Yes, I would like to join in that conversation with Vinod. As an engineer, I know the value of 2 square root or 3 square root, because if we are making certain blocks and that have to be fit in a particular space where the area is 2 square root, we want to know the sides of each of these blocks so they can fit in there. Similarly, in the sciences, there are elements, and those elements can be described by several parts, which may require square root of 2 and square root of 3. So there are applications.
That's nice to know. But I think at the school level, the kids ought to know that there are applications.
Yes. These are, no, I'm not in any case denying the value of applications. I think applications are very important and where we can point out. The point is about pointing out all these things or engaging with them without alienating children, right? In a language that children can understand, in a language that children can speak and own to some extent, right? Now, with children, it's like saying, you eat your spinach today, it'll be very good for you later, right? Now, that never goes down very well. I mean, when it goes down well, you're happy, but doesn't always go down, right? Same thing. If you're saying that you're going to learn all these things because it's going to be very important for things later, unless you see yourself, right? I mean, if it's of great importance to engineering, great. But do I see myself as an engineer, right? Do I envision myself doing these things, creating all this knowledge? Then otherwise, there is always that thing that, oh, it's beautiful stuff. So let somebody do it, right? Why should I, right? So, I mean, with algorithms, many students, or theory of computation, and many students come and ask, it's great, but why should I? It's wonderful stuff, but why should I learn this? Let somebody else, somebody else who is very smart, let them learn this, right? So I want context. I want something that I can understand, that I can engage with, right? That's the plea that the child is making, that the student is making at that point. Can you talk to me in my language, right? Not in the sense of the mother tongue, but in something that I speak, that I'm comfortable with.
I think Musu Kumari had a question and we keep asking without giving her a chance.
Yeah, I think she should speak. I mean, she just wanted to put on chat, but Muthukumari, why don't you?
She has written in chat that I'm a school teacher. I would like to ask a question. By knowing your experience, even now the situation in 1990s are still exist. Same situation exists here now. Kuruvama never had a chance to enter into science world today. Textbooks, a Bible of classroom, are alien to students because it's been decided by higher education officers who never have any classroom experience as well as no idea about student psychology. They decided even those textbook committee included teachers, but they don't have any power to influence them. What is your opinion on all that?
Yeah. So as I said, I've been part of both sides of this game. So I've been on committees, and I'm talking about a few from below as well. And I completely agree with Muthukumari on the dynamics that happens in textbook committees, right? Now, teachers are present, but what influence do they have? And also the teachers that are present, what are they bringing into the textbook writing? So when will textbooks become student friendly? I don't know, right? I wish I had the answer, but I would like them to be. And they are becoming more and more friendly over the years, I would say, compared to what I saw in 1990 to now. They are better in some ways. When I was part of the 2005 national curriculum exercise, I saw that, the mathematics series that NCERT produced, the primary textbooks were far better than anything that, had existed earlier, and they were excellent. By middle school, not, the change was less. It was better, but not much better.
Yeah. I think I don't
very, very
I don't share her pessimism completely, but I do share it partially. Partially because I think there needs to be done a little bit more of making the textbook more interesting and understandable and all that. But the other part is that let's not forget, all of us are trained in the same textbook structure that and we are good people. I think we are learned and we have done some knowledge building over the years. So clearly blaming the system is probably not a very good idea. That's, as I said, that's the other side of the argument. Very good. Any other question? Anybody has a final comment?
Certainly there are more pictures now in the textbooks than before.
Oh, I see.
And expressing root 2 plus root 3 can be done by approximation, and that may be sufficient for many people to begin with. To say exactly, to understand square root 2 plus square root 3 and understand that they are not rational numbers, that's a different understanding. So, so this engineering understanding is mainly with approximations.
But the question you raised from the students in schools at the university, they keep on raising same questions. It's because they have not gotten to that higher stage. When they get to that higher stage, then they will appreciate. And I mean, in business school, I teach operations management to graduate and undergraduate students. And they ask same exact questions like you narrated, questioning why am I covering a certain aspect or Queen theory and all those, where are these applied and what will we do with them? We are going to be managers. Then we have to sell to them what we do and what we teach, because we have few steps ahead of them. And I guess that is one argument I have used, and successfully mostly. Thank you.
Very good.
And what is
well, thank you very much, Dr. Ramanujam, for coming over and giving this beautiful talk. What was that?
What Professor Ramanujam said about explaining group theory, that requires certain mathematical maturity, but even understanding the classical mathematics, like Euclid's question of constructing regular n-gons. That has to do with elements of finite order in the Euclidean group of congruences and similarities. To bring to that level, so we can indicate that to our students, that this is the development, and first of all, set theory should be used more and more. And with set theory, the notion like groups or lattices, that may be introduced earlier than usual.
Let me tell you another thing before I leave. At Seton Hall University, where I teach, it's a Catholic university. And after years of debates, we made study of Bhagavad Gita mandatory for every student.
Wonderful.
Yeah, and students keep on raising questions. Why do I have to read this book? Why do I have to know about something that glorifies killing and glorifies destruction and all those? Well, we decided. It took us 7 years, 50% committee that brought from people from all parts of the university. And we finally decided that we can't just let them learn from Bible that is 2,000 years old. We want people to know what happened thousands of years before Bible came up, because people lived, and how they lived, what they did is very important. And I would not vote until they satisfied me. And finally, after 7 years of debate, they voted in favor of a theme they came up with. They said, we at Seton Hall University will cover principles of Catholicism, but we added the line, but not exclusively. And by that, those two words, not exclusively, we brought in other religions. All religions eventually were skimmed out. But Bhagavad Gita stayed. This has been now 15 years, and it's going on. Every student, undergraduate, and we take typically 1,600 to 1,700 undergraduate students every year. And we had to train many teachers. We brought in swamis and gurus to train our professors how to teach the principles of Bhagavad Gita. And that is what happens. Those people who are ahead of you, they decide what should be taught or what should be done to you. When you are born, someone had to decide whether you live or you die. And you cannot keep questioning everything. You have to have some faith in those who had been ahead of you.
Actually, I had a similar experience at the City University of New York.
Yeah, we are about 14 miles from New York City.
Distinguished professor of philosophy did not know Shankaracharya.
Yeah, I mean, that's shame and incomplete knowledge, definitely.
Very good.
Can I say just a couple of lines, please, if you don't mind?
Yeah.
It's not getting too late. I just want to bring it back to the mathematics and the sciences. I think, because I mean, you're all of you in the US, and it's a very different environment out there. I think the real question, and I see this in the sciences also because I'm a physicist, is not really catering to the top 1%, because as you pointed out, you whatever the classroom education, all of you did well, studied well, were successful in your careers. We were also successful in our careers. But the question is really how this curriculum is geared towards the Gaussian average of the 70% in the classroom, who actually are well below the average expectation of what is the expectation from above, compared to what is actually the truth below, or the reality below. And I think this is a huge problem in India. I don't know anything about the US, but definitely in India, I think not just the maths and sciences, but all of education should not cater to that 1%. It should cater to that 70%. And that is simply something that I think these committees have missed out. So I just wanted to put that opinion of mine out there. Thank you.
Last comment.
I think I've said.
Okay, very good. Well, thank you very much again for everybody to attending this, and it was very successful. And we look forward to seeing all of you again in our next webinar, which is in November. And Dr. Ravindra Kulkarni is going to speak on what is the topic you will speak on, Ravi?
Decide. Not yet decided.
What's that?
I'm not making a decision on what to speak on.
Oh, okay. But then you are going to tell us the date as well as the topic very soon.
Yes,
and we will put that on our website. Thank you very much. Thanks for coming, all of you. Very good.
Thank you.
Bye-bye.
Bye-bye.
Bye-bye.